The next process in the manufacture of ceramics is the firing process. The action of heat on clay and mixture of clay with other materials is really the basis of the ceramic industry. These substances acquire durability and many other favorable qualities not present in other substances when they are heated at higher temperatures. Finally dried articles are known as blanks. In such cases, glaze is put on the blanks before firing, but in most cases, blanks are fired to produce biscuits. Glazed products are obtained by putting glaze on cold biscuits and then firing. The vitrification of ceramic products and the chemical conversion of dehydration, oxidation, and calcination are carried out in kilns that may be operated either in a continuous or in a periodic manner. Muffle kilns in which the flames heat the outside of a refractory chamber containing the article to be fired are also used. The flames in these kilns do not enter the chamber. Gas, coal, and oil are the most common fuels for firing. In some cases, electricity is also used. Various chemical and physical changes that take place during firing process are dehydration of adsorbed and chemically combined water. The rate of dehydration is maximum at about 500 degrees centigrade. The second process that occurs is the oxidation of oxidizable organic matter, sulfur compounds, and ferrous compounds between 300 degrees centigrade and 900 degrees centigrade. Third process that occurs is the decomposition of carbonates of calcium and magnesium to form oxides and carbon dioxide. Next, the process which occurs is the vitrification or the melting of some constituents to a glassy mass. This occurs so as to cover up and bond the unmelted mass or particles on cooling. During vitrification process, shrinkage of volume also takes place, and the extent of the shrinkage is a measure of the progress of firing. The degree of shrinkage mainly depends upon the temperature, which is between 950 to 1050 degrees centigrade for common glaze, and time required for the process. Next process involved is the reduction. Reduction involves color dilution of the processed article. During reduction, the air supply to the kiln is cut off. As a result, transition metal ions are reduced from higher to lower oxidation state. Next process is the annealing. It is the slow cooling of the fired article. And finally comes the decoration. Underglaze decoration is developed on the ware below a layer of transparent glaze, and overglaze is applied over the glaze, which may be opaque. After the firing process is over, glazing takes place. Glazing is important especially in whitewares and tablewares. A glaze is a thin coating of glass that is melted onto the surface of the more or less porous ceramic material. In other words, a glaze is applied on the surface to cover the pores which are present almost in all ceramics except hard porcelain. In the case of common clay products obtained at low temperature, the number of pores is large. But they are also present in small numbers in whitewares, which are obtained at comparatively higher temperature. In the case of hard porcelain, these pores are closed up as a result of vitrification to about 1400 degrees centigrade temperature. Uh, a glaze is a fine powder consisting of a mixture of glass forming materials of proper composition, that for example lead silicates, borosilicates, etc. A glaze contains refractory materials such as feldspar, silica, and china clay, and fluxes such as soda, potash, fluorspar, and borax in different proportions. Different combinations of these materials in different temperatures at which they are fired gives a wide range of texture and quality. The glaze may be put on the ware by dipping, spraying, pouring, or brushing. In actual practice, glazing may be performed in the manner such as the glazing ingredients are finely powdered and mixed in definite proportions. The mixture is then mixed with requisite amount of water, and In order to get a slip of necessary consistency, the slip is then applied either to the dry blanks or more frequently to the biscuits by dipping, pouring, spraying, or brushing with a great care. The purpose of glazing is manifold. For example, its purpose is to produce a decorative effect, to improve the appearance of the article, to improve the durability of the ceramic article, to provide a smooth and glossy surface to the glazed material, to protect the article from the environmental and atmospheric effects, and to make the surface impervious to liquids. Glazes are useful both in the case of porous as well as in dense bodies. In porous bodies, the glazes acts as seals and prevent penetration of water, while in dense bodies, they make the surface smoother and brilliant. A glaze is formed on the surface of the shaped ceramic article during the firing. Before firing, the glaze covers the surface of the ceramic article in the form of dry powder. A glaze on the surface of a ceramic article must not get too fluid. If it were fired to the degree of fluidity required for flowing a glass bottle, it would run off the ceramic article. Glazes are the products of a reaction between acidic and basic oxides. Acetic oxides used in the formation of glazes are silica, that is SiO2, introduced as sand, flint, feldspar or stone, and boric acid H3BO3, introduced as borax or as crystal boric acid. The basic oxides used are alkalis and lime. Different types of oxides composing the glaze are classified into four groups. The first group is the R2O, that is, for example, potassium oxide, sodium oxide. Uh, Second group is the RO group, that is lead oxide, calcium oxide. Third group is the R2O3, for example, boric oxide, B2O3, aluminum oxide, Al2O3. And the last group is the RO2, that is zirconium oxide, silicon oxide, titanium oxide, etc. Magnesium carbonate, tin oxide, antimony oxide, lead oxide, barium carbonate, strontium carbonate, etc. are also used occasionally. The glazing mixture free from iron and other coloring pigments form colorless glaze. Colored metal oxides or pigments are mixed in proper proportions for color glazing. For example, for red and brown colors, iron oxide is used. For cream and yellowish tinge, iron oxide and lime are used. For green colors, copper oxide is used, and for blue colors, cobalt blues are used. It should be noted that alumina is an important constituent in ceramic glazes, and theoretically it is a basic oxide, but in the composition of glaze it has been considered as neutral oxide. Glazes can be divided into three classes according to the way in which they are prepared. The first type is known as the raw glaze, which are prepared from materials which are insoluble in water. Second type is known as the fret glazes. In these, some materials which are soluble in water are first melted with silica and then mixed with other materials insoluble in water. The third type of glaze are known as the salt glazes. These are produced by throwing salt into the fire in the later stages of the firing process. Next process in ceramics is the frits. The preparation of frit is very important for the composition of glaze suitable for temperatures lower than 1200 degrees centigrade. Glazes are applied to the surface of ceramic articles in the form of finely powdered particles suspended in water. Various fluxes such as soda, potash, boric acid, and borax are water soluble and important for low temperature glazes. These are converted into a non-water soluble substance by mixing them with silica and heating the mixture at or above its melting point. Lead oxide is poisonous and hence it should not be used directly in the glaze slip. It is first added to the frit where it forms a water insoluble silicate. Most lead silicates are insoluble in water and dilute acids. Lead should never be used in frits which contain borax or boric acid. Lead should be used as lead bisilicate in cases where the frits contain boric acid, as lead bisilicate is insoluble in water. The last but not the least process which comes in the manufacturing of ceramics is the decoration. Now there are two types of decorations. One is known as the underglaze and another is known as the overglaze. In the case of underglaze decoration, the colors in the glaze fuse directly while in the case of overglaze decoration they fuse together with the help of a soft flux. In case of underglaze, the decorations are first prepared by first calcining, coloring metal oxides with such material as china clay, feldspar, alumina, etc. The calcined mixture is then disintegrated to extremely fine powder. The powder is mixed with gum or oils and applied to the biscuit either by a brush or by spraying. In case of china or porcelain, clay or porcelain, the underglaze decoration is dried at room temperature. The ware after drying is covered with the glaze as usual and then fired. Care should be taken that glaze must react with the color but not dissolve the color. In case of overglaze, the decoration is put on the glaze and then fired. In other words, overglaze colors are applied on top of the glaze and they are prepared by mixing the coloring oxides with the frits of low softening temperature. Colored glaze can be prepared by addition of coloring oxides.